Hello and welcome to our um, 596 project for fall 2021. We're going to be demoing our code here, and I'm Abdulaziz Al Katan, and my friend is.
I'm Chaitanya Patel.
And yeah, just a quick disclaimer: we did run this code beforehand because some of the algorithms took a long time to finish going through everything. So that's why you're going to see the results immediately instead of just running the code again. And we begin by processing, loading our data, processing them, and turning it into something we can manipulate and get results out of. So we began by collecting many .csv files, which had many sentiments, and then took all the elements we needed and put them into one big file called the final file right here. And then we loaded everything with the positive, negative, neutral sentiments, and then to visualize what we've got so far in our big file, you can see these percentages for each of the negative, positive, and neutral um, elements, and then a histogram to also kind of demonstrate all those sentiments. The pink one being negative, black one being positive, and yellow being neutral. So, and then we go to data processing, um, which just which just finalizes everything about um, the data set that we have, the big file, and normalizes everything, basically, removing any outliers and whatnot from the data set. So, moving on to the training and actual algorithm implementation, my friend is going to take it from here.
As mentioned in our presentation, we had six different models classified under two different methods. We had logistic regression, decision tree, and random forest. These topics were known to us, hence we put them in method one. In method two, we had topics that were not unfamiliar or have never seen before. That did take a bit time um, in understanding, but those included the support vector, the native naive bias, and the Bernoulli naive bias. As my friend goes through the code, I will explain what each one did. We first go to the naive bias, and after calculating, we found out that as you can see, the confusion matrix shows a good result, but it is not the best that we have seen. We also presented a result for accuracy in the form of a graph so that it can help us better analyze what this can do. Then we jump to the Bernoulli's naive bias, where again, as you can see, the confusion matrix shows good results, but again, not enough. As well as the accuracy shows, as well as the accuracy shows you what how accurate that system was. Then we go to support vector. This was an unfamiliar topic for us. It did take some time to get through it, but we did get through it, and we saw that it had a very good confusion matrix as well as accuracy, as you can see in the graph and the matrix. But then we moved on to a topic that was known to us, which is logistic regression. Um, that also did show a very good matrix as well as a very good accuracy graph, as you can see. We then go to decision trees. That is also again the one that we did in class. This didn't quite show a good confusion matrix since it didn't take in much data, but that was expected. The accuracy chart again shows you how good the system did. Then we move on to random forest. Random forest did take quite a time to load, hence, as my friend said, these results were preloaded before the recording. The confusion matrix did show promising results, but they were not um, as they were not the best. The accuracy graph also shows you how well the system did, but again, did lack from the other ones. Lastly, we try to put all the regression model graphs or accuracies for all the models into one graph to analyze which one did perform the best. We figured out that the linear regression and the support vector did perform the best, where the linear regression was more consistent, but there were some instances where the support vector took over. We also observed as predicted that the decision tree would perform the lowest since it didn't take in much data, and that can be observed here. Back to you.
And yeah, I forgot to mention that we're using Jupyter Notebook to code everything, which is an extension of Python basically, and it uses the same syntax as Python, and we used many other libraries from the Anaconda um, program. So it was a much more comfortable workspace for us. And for the accuracy testing, we did choose K-fold instead of the regular three-way split, the train, validation, and test data, which is what we were used to in our programming assignments in this course. So that was a nice change and a bit of a challenge since it was a new method to go over. But these are all the results that the K-fold accuracy validation yielded. And yeah, that was our demo. Thank you very much, and have a great winter break.